All right, can you guys, here we go. I'm going to pretend I wasn't here yesterday. You lead me through today. So in Gym A, the announcement is made. Go ahead and clear your calculators. I'm ready to fly up and down the rows and not stop. So what are you going to do? Second plus 7. Over to all, not all RAM, over to all. Reset. I'm going to look for that screen or a RAM cleared screen up on your calculator, and we're good to go. Going to go quick. 74 students. I got to check calculators, so hopefully it goes quick. We all good? None of us are going to be that kid that starts freaking out and getting all awkward with it. We're going to remember how to do this, even the kids that are not trying it right now. We're good? Okay? Because I'm going to be ticked if some of you guys that aren't trying it are the ones that don't know how to do it. So, okay? Questions? Okay. The entire test is done in what? Pen. And until you get to the construction or any graphing that you do, reminder, you will have a sheet of extra graph paper at the end of your exam. Okay, at the end of your exam. Good? I will not grade this or look at it. That is for your own personal use during the midterm. Okay? You will also have, if needed, but I highly doubt you'll even look at it, you'll have the formula sheet attached as well. The only thing really that maybe you could use the formula sheet for is Pythagorean theorem or quadratic formula. Anything else we haven't discussed yet this year. So, okay, that'll be attached to your midterm. Time limit on the midterm? 2 hours. Yep, that's it. 2 hours and we're done. Any other little detail questions? One last thing. Have I talked to you about how I'm going to give you your grades? No? Well, on Monday I'll hand it back, but I'm going to post them to Aspen like I usually do any test or quiz. Okay? So you don't have to email me what did I get or stop by what did I get. Once I grade all your midterms, I'll put them into Aspen and you guys can see for yourself. I just want to warn you though, the number you see is out of 80, remember, because that's how many points there are. It's not a percent. So you see the number 74 there, that doesn't mean 74%. That means you got a 74 out of 80, okay? Also, you probably will see this here. You'll see the word exempt next to your midterm grade. Here is why. The only way I can, in Aspen, for me to put your midterm grade so you can see it is to put it in second quarter. But as you guys know, it doesn't count towards the second quarter. It's just a quarter on its own. So the only way I can have you guys see it is putting it in the second quarter. So the exempt means it doesn't count towards quarter 2. All right, so don't freak out about that. And again, this is not a percent I'm going to put in. It is out of 80. All right, please realize that. Kids freak out. I got a 74. Oh my, no, it's out of 80. All right, all good? Okay, and then whenever I'm done grading, hopefully by Wednesday or Thursday, I'll get them all done. And then I'll post them. Okay? No curve, remember? All right, so whatever that number is, it's going to be out of 80, and that's it. All right, so that's it for what I have to tell you. Some little details. Let's open up the club again. And last period was interesting. I got 2-3 questions, and then the 25 minutes of just doing studying on their own. Okay? You guys don't have any questions for me. I'm not going to force it. So let's open it up here to whatever you guys have. Remember, take your time on the multiple choices. Okay, I think that's the toughest part, and -2, -2, -2, -2 can add up pretty quickly for you. All right, let's go to Naomi. Charlotte, you're on deck.
Page 41.
In the packet? Okay. All right, well, I had it up there. Okay. Let me cut this out. Ooh, a little too large. Okay, here we go, a little proof action. Okay, prove this beast is isosceles. What's an isosceles triangle consist of? Congruent sides, or you could go angles if you wanted to. Whatever's easiest for you guys to perform on triangle DCE here. All right, so I need at least two sides or two angles congruent in triangle DCE. My best bet, I'm sure there's other ways, would be to prove those two outside triangles congruent. That's my best bet. Yes, no? So I can go a little CPCTC on angle D and angle E. All right, so can anybody help me get those two outside triangles congruent? Because I have nothing. 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 What's up, Marlies?
CA is congruent.
Okay, here we go. I can start off by saying because angle 1 and 2 are congruent, so CA and CB. And that is in a triangle. Congruent sides across from congruent angles. Okay, got us a pair of sides. Thanks, Marlies. Got us a pair of sides there. Still need two more pairs of something, Maya, go.
Can't you just prove the other triangles congruent? Then you already have triangles.
Okay, so you want to prove the two overlapping ones. So you can do that way. Yes, it's probably shorter than the way I'm doing it, just so you guys know. Here's what Maya's talking about. Take that triangle right now, which has side angle side already in it, and prove it congruent to this triangle here. Everyone see the overlapping ones that are side angle side? Side angle side, side angle side, and then do CPCTC. Okay, that's fine. All right, let me just, because there are a couple theorems I want to go over here. How would you use angle 1 and 2 to get angles on those two outside ones I've been talking about? Mike? Okay, first thing you got to tell me, though, is angle 1 and what's its supplement? Angle 2 is not its supplement. Angle DAC are supplementary. And then you can say angle 2 and angle EBC are supplementary. Anybody remember this reason? This is the only way I'm doing it this way. Linear pairs are supplementary. Yep. And then you could say angle DAC and EBC are congruent because supplements of congruent angles are congruent. How we doing here, Naomi? All right?
Yeah.
Okay, then I would still need one more pair of something here. And then what would I do with these two here to get another pair of sides? Take AB reflexive, subtract them, and then I would have side angle side on the two outside ones. And that would lead me to a pair of angles or a pair of sides you're choosing, and then it would make it isosceles. Good deal? Okay, two different ways. What's up, Marlies? Go ahead.
What's the reason once you said triangle DC is isosceles?
It depends on what you did. If you did the two angles, I would say two congruent angles imply isosceles triangle. Or if you use sides, replace angles with sides. Okay? Actually, I'd probably put in a, because two congruent angles in any figure doesn't mean it's, I would put in a triangle to make sure we know we're working in a triangle there. Okay, Charlotte, what's up?
Page 28, number 7.
Page 28. Okay. Parallel perpendicular lines. Okay. Okay, we have A perpendicular to B. And we also have A perpendicular to C. Got it. Try to prove 3 and 4 are supplementary. Okay. Well, first from the givens here, what do we notice about B and C right from the givens? It's not parallel to the same line. Perpendicular to the same line. Anybody remember the theorem we had? Two lines perpendicular to the same line are parallel. So we can say A, not A, sorry. That's the line they're all perpendicular to. We can say B is parallel to C. Two lines perpendicular to the same line are parallel. And that helps tremendously, knowing B and C are parallel. Because what type of angles are 3 and 4 now? Ready? Here's 4, here's 3. They're both on the parallel lines cut by transversal D, and they're called what? Same side interior. And what do I know about same side interiors? They're supplementary. Done. All right, so now I can say 3 is supplementary to 4. Parallel lines imply same side interior supplementary. All good? Okay, I know you could probably put right angles here, but the right angles would be at 1 and 2, and now it's kind of hard to get to 3 and 4 from there without knowing the lines are parallel. Marlise, going deep. Construct an altitude. You honors kids think alike, huh? That's what we did last period. Kind of giving away here my secrets. Okay, before I go over the construction, everything you know about an altitude. Where's it start? Vertex, and it is perpendicular to the opposite side. All right, you don't have to just have it in a triangle either. It can be in a parallelogram. Any quadrilateral can have a altitude as well, as long as it's from a vertex, what to the opposite side? Perpendicular. So I'll go from this vertice perpendicular to the opposite side. So I take my compass, I put my compass point on the vertice I'm starting from, and I'm going to try to draw an arc that intersects the opposite side in how many spots? Twice, and I don't think on this triangle anyway you're going to be able to do it. I don't know, maybe some of you can. I had to scale down mine a little bit. If I can't, what's my suggestion? Extend your side with a straight edge, not free-handed it. And I know I'm going against what I just said, but okay, now you can make your arc that intersects in 2 spots. Now you go to both points of intersection and make 2 more arcs below it that intersect. So 1, 2. I take my straight edge, line it up with the vertice in that point of intersection, and draw my altitude in. You do not have to draw it all the way through like this. You can just end it up on the opposite sides fine. Hold on, Mike. There's a second part of this. I draw in at least one more or two more. They all intersect at a point called the orthocenter. You do not need to know a special fact about it, but I would know the following. If you have an acute triangle, if you have an obtuse triangle, or if you have a right triangle, where is the orthocenter located in each one? If you have an acute triangle, it's got to be somewhere inside because all three altitudes would be located inside. If you have obtuse, outside because one of the altitudes would be outside. And if you have a right triangle, the two legs are altitudes. In a right triangle, the two legs are altitudes, which means where they intersect would be your orthocenter. Okay? Or at least we good? Okay, that's what you got to do with every vocabulary term. All right, Marlise happened to pick altitudes. I would do the same thing I just did for medians. What is it? Construct it. Where does it intersect? What's so special about it? All right, go ahead, Mike.
When you're drawing the altitude, do you have to keep the compass the same opening the whole time?
For the last two, yes. But once you do make this first arc here that intersects twice, you can open or close it. But the next two arcs you do have to be the same. Yep. Natalie?
Okay, so
Okay.
for 54.
Page 54?
Yeah, page 54.
Go ahead.
I don't understand for the partition when you're supposed to add or like subtract.
Okay, it depends what direction you're going. Like if you're on the x-axis, like let me show you two different examples right now. That's not a good one. Okay, letter B. Look at letter B. What's your first x coordinate?
It's -9.
And you're going to what?
1.
So I got to add on if I'm going to go to the right. See what I mean? If you think about the x-axis from -9 to 1, I'm going to have to add on to get to 1. Versus if you look at letter C, you're going from 8 to
4.
Going to the left. So I got to subtract whatever I have there. Okay? See what I mean? And the same thing on the y-axis. If you're going up 3 to 8, on part B, 3 to 8, I'm going to have to add something to 3 to get to 8. Because remember, your coordinate has to be somewhere in between 3 and 8. And if you subtract, you're going in the opposite direction. You're not going towards 8. See what I mean? And then finally, where is it? Nope. Okay, look at part E. You're on your y-axis, where are you going? 9 to?
-3.
So where are you going?
You're going down.
So you got to subtract. You don't want to go above 9 and add. You want to subtract and go below 9. Good?
Yeah.
Okay. Anybody else? More. Here we go, Naomi. Page 49. We didn't do this one yesterday? No. No? Okay. We must have done it in the other classes then. Okay. I got a triangle, isosceles. (17, 17, 16). G is the centroid, find AG. Okay, so let's go over everything we know here. What's the centroid fact I'm probably going to use here eventually? 2 to 1, right? It splits the median up in 2 to 1. So what I'm going to have to draw here is the median through A going through G. Okay? So I got to draw the median. All right, medians go to where? Midpoint. So it just broke this side of 16 up into what? 8 and 8. All right? Flow with me here. And what's the fact about the centroid again? 2 to 1. Did we go over the 2 to 1? I have 3 classes, so where's the 2, where's the 1? Somebody asked that in this class, or was that a different class? How do you know where the 2 and the 1 part are? The 2 is from the vertex to the centroid, and the 1 part is from the centroid to the midpoint. And it's looking for what is the length of AG, right? Length of AG. Well, I'm not going to find this until I know the length of what? There's no way I can find this unless I know the length of what? The median. Everyone agrees? I can't do it because I can do this. 2x plus x is equal to the length of the median. And then I can find what AG is, but I need the length of the median. All right, how do I get the length of the median? That's why I gave you this little hint right here. A median in an isosceles triangle is also an altitude. What can I put here now? Anybody know how I'm going to find the median now? I have 2 right triangles, or I know 2 of the sides. I can do Pythagorean theorem. Give me a leg. Leg, 8 squared. Other leg, trying to find it. That's the median. And what's the hypotenuse? 17 squared. All right. How do we solve that? Go ahead, solve it. Median length should be 15, yep. So the centroid breaks the length of 15 up into 2 to 1. So 2x plus x equals 15. You guys solve it, you end up getting 3x equals 15, x equals. Okay, again, you got to have some darn discipline here on Tuesday. Especially for an honors level midterm here, it's probably not going to be x. What do I need to do to 5? Because that's not my answer. I'm looking for AG, which is the 2 part of 2 to 1. So I got to take 5 and multiply it by 2. So I was really looking for a distance of 10 there. Okay. So I need to know the length of the median to break it up into 2 to 1. Number 3 below it, I'm not going to do that one, but number 3 below it is an equilateral triangle. It's still the same thing. Equilateral triangle is still considered isosceles. So you still do the same exact method here. Others? More questions here? Topics. Remember, the worst that could happen is I could tell you it's not on there. Don't worry about it. That's the worst. Maya. Okay, what about them? What about, do you have one in like an example? Because I put a ton in your packet there. So we're just choosing one? We haven't gone over one yet? Okay. I know that's Unit 5, which is where we're at right now in the packet. Anybody? I'm just going to choose 7 then. First one I saw, Indirect Proof. Remember, 1 proof on there, 6 points. Come on. I'm not going to tell you what type it is. But I'm sure you're going to have to do some work for it. It's not going to be a 2-stepper. Okay, why did I, first of all, how did I know this was indirect? Okay, you see that on the midterm, something's not happening, you know you got to do it indirectly. Because probably in the directions it won't say do this indirectly if it is an indirect proof. Okay, after you put your givens in, you have to put your assumption in, something we're going to assume is true. All right, here we go. How do I obtain my assumption? Where do I look to get the assumption? In the proof statement. The proof statement. What do I do to the proof statement? Assume what? The opposite is true. So BD is not perpendicular, so it's going to be BD is perpendicular to AC. That's my assumption. And you can use that now. Use it in your proof. Mark the diagram with it, okay? So here's what I have right now in my proof. I have those two sides, AD and DC, and the right angles. Still got to put the right angles in, but. All right, you know there's got to contradict. So what are you going to contradict? One of the givens, preferably the one that says not equal to, right? Okay, so we need to prove AB is equal to BC. So somewhere in my statements, I want a statement that says AB is equal to BC. All right, how are we going to do that? Prove the triangle's congruent. First thing, I just heard somebody say BD congruent to itself. You want to contradict one of your givens. Reflexive. I still haven't put something in, though. Yeah, be disciplined here. Points come off the board quick, remember. Got to say something that they are right angles. Angle BDA and angle BDC are right angles. Perpendicular lines form right angles. And then say they're congruent. All right, what's the method they're congruent now? Triangles. Side angle, side, yep. Triangle BDA congruent to triangle BDC. Side angle, side. And then now, what are we going to say is true now? AB and BC congruent by CPCTC. That's a problem, isn't it? Writing this down on your paper, that's a huge problem. Because you told me in the givens it wasn't equal. So that's a contradiction, so your assumption must be false, meaning the opposite. What's the opposite? What we're trying to prove, BD not perpendicular to AC. And everyone remember our last reason here? Assumption led to a contradiction. And yes, you have to tell me, where is that contradiction? What did we contradict? Step one, right? AB not equal to BC, and where did we contradict it? Step 7. Whew, there it is, indirect proof. One of the many proofs that could possibly be there. Did we go over the ways? I mean, not the ways. Did we go over all the different proofs that are an option? You guys must have been the only class. All right, why don't we do that right now then? Again, I don't want your focus on the proofs because it's one question at the end, but let's go unit by unit. Obviously, unit 2 I'm not talking about because it's not going to be 2 steps and you're done. Unit 3, we started doing actual little longer proofs with given parallel lines and prove parallel lines. Okay. Those are the two types of proofs in Unit 3. Unit 4 was a big one. That's where we started proving triangles congruent. Anybody remember the next day after I showed you how to prove? You just did it on the indirect proof, but after you prove triangles congruent? CP/CTC proofs. And then it really knocked your socks off at the end of this unit. You wanted to prove a pair of triangles congruent, but it wasn't possible. So what did we do then? I had to go to another set of triangles, right? So I could get a pair of corresponding parts to prove the originals. Okay, so prove a pair of triangles. Congruent. I know this is wordy, but prove a pair of triangles congruent to get another pair congruent. Big timers there. And that was it for 4. Unit 5, there was only one type of proof, and we just went over that one. That was an indirect proof. And the unit we just finished, 6, that was also a big proof unit. What do we do in Unit 6? Given a quadrilateral, and when I say a quadrilateral, I'm talking any of them. Given a parallelogram, given a rectangle, rhombus. We also did prove a quad. And then there was one other type of proof we did at the end. We had a lot of practice with it. Coordinate proof, yep, on the graph, slope, midpoint, distance. Look, you guys could guess all you want. Just make sure you're good at all of these here, okay? If you want me to send you any extras, reach out to me. I'm on. No. The only type of indirect proof there'll be is the one we just did together, okay? So there are all the different types of proof we've done so far. And good news heading into the second semester, we only have one more type of proof to do, and that's circles. And that's it. Okay? Nothing to worry about now. Okay, but there's only one type of proof we have left. Also, a couple of constructions left in the circle unit, and that's it. Any other last minute questions here? Again, don't feel bashful or embarrassed or scared to reach out to me for extra problems on a certain topic. I think probably at least 10 people have done it already, so keep reaching out. All right, bring your questions tomorrow still. On the assignment sheet, I've recommended some problems out of the book in the packet tonight if you want to try those. And then remember, yesterday at the beginning of class, I gave you 3 topics to start. All right, 3 topics that you know will definitely be on there. Good session today.